Hey you guys, it's Mrs. Turner, and I'm here today with a screencast of the notes for balanced and unbalanced forces. So if you don't already have your notes sheets, you need to come see me before you go any farther in this video. So go ahead and pause and come get those if you don't have them. Okay, so let's get started. Our essential questions in these notes, the things that you want to be able to answer at the end. What are balanced and unbalanced forces? And how do unbalanced forces cause a change of position, direction, and speed of an object when they are acted upon by unbalanced forces? Okay, so let's start out just talking about force a little bit. A force is a push or a pull that causes an object to stop, move, or change direction. Forces push downward toward the Earth's center. That's called gravity. Or they push upward on an object. That's a normal force or a supporting force. So they may or may not cause movement. And so if you look here, example 1, the book is pushing down on the table. It's pushing down because of the force of gravity, and the table is actually pushing back up on the book. So we have an easy time thinking about the book pushing down, but what we usually don't think about is the opposite force, which is the table pushing up on the book. Example 2, which is not in the picture, is a car accelerating. It's changing speed and direction because the force that is produced by the car when you step on the gas is greater than the force that's keeping it in place. And so if you have these notes, you need to stop, cut these out, and get them in your notebook. Okay, and then come back. If you're back, here we go. Balanced forces are forces that are equal in size and they act in opposite directions. Okay, so when there's a balanced force, the object stays still or it continues at the same speed and in the same direction. So that part's confusing. Like, we all can understand that if the forces are equal and opposite, that the object might stay still. But also, if an object is moving at a constant speed in the same direction, then that also shows that we have balanced forces. So whenever anything's moving at a constant speed in the same direction, the forces are balanced. And when something is not moving, the forces are also balanced. So here are some examples of balanced and forces. The first one is a car at rest. Okay, right here. This is at rest, so it is a balanced force. This one, baby sitting on the road, balanced force because it's not moving. Cup sitting on the table, not moving, it's a balanced force. Okay, here's where we get confused sometimes. This horse, as long as it's moving at a constant speed and in the same direction, would be considered having balanced forces. Same thing with this motorcycle. As long as it's moving at a constant speed, it's not going faster or slower, and it's not changing directions, its force is also balanced. Unbalanced forces are two forces that are unequal in size and opposite in direction. So you can think of this like a tug-of-war. They always cause a change in motion in one of these areas, either in position, in direction, or in speed. Here are some examples of unbalanced forces. Okay, from doing the station labs, some of this might look familiar to you. This N stands for newtons. That's a way that we measure force. So if there's 20 newtons going this direction and only 10 newtons going this direction, then this box would move left. Okay, same thing here. If horse number 2 is the stronger of the two horses, then when they both start pulling, horse number 2 is going to be able to create more force, and so there's going to be more force going this way, and they're both going to end up moving that way. Same thing here, you're changing direction when you're turning, and so there's force that's pushing you in a different direction. And here, if you have two kids pulling on your arms, whoever is the strongest is going to determine they are going to be exerting the most force whichever one of these, and that's the direction that you will move. Okay, so let's look at this really quickly. Which way are these ice skaters going to move? So they have ice skates on. This person is exerting 3 newtons of force. This person is exerting 2 newtons of force. Which way are they going to move? Okay, they would actually move this direction, right? Because there's more force going this way, so they'd be moving to the right. This one would be moving backwards. This one would be moving forward. Net force is the overall force that is acting on an object, and it's measured in newtons. So you can see it's really just a subtraction. The net force here is 1 newton. This one is 3 newtons, 2 newtons. The net force, or the difference between them, is 1 newton. Okay, obviously, since you are doing the screencast on your own, we may not be doing this portion right now. We will do it at some point during class. It just kind of depends on when you're taking your notes. But we will have people come up and present an example of a balanced force, and we will have some people come up and present an unbalanced force. So I want you to think about, if you are called upon to demonstrate a balanced force or an unbalanced force, what would you do? You need to have one prepared in case I ask you to come up and demonstrate that, okay? Here's the second INB template. If you have this, you need to stop now and cut that out, okay, and get that glued. And it says, glue this side down. Do not glue down the petals, okay? So you're making kind of like a flower. You're going to be able to lift each of these tabs, and you're going to decide if each force is balanced or unbalanced, okay? All right, how do unbalanced forces cause a change in position of an object? So if you think of a skier at the top of the hill, he's just standing there, that's a balanced force. If another skier runs into him, that is an unbalanced force, causes him to fall. Okay, the unbalanced force caused his position. Oh, sorry, I have the yawns today. It caused his position to change. So when someone ran into him, then that was an unbalanced force because he was balanced before that. And then, how do unbalanced forces cause a change in the direction of an object? If you have a skier at the top of the hill, that's a balanced force. And then the skier decides to point her skis down the hill and push off. That is an unbalanced force. This unbalanced force causes her to change direction. Balanced and unbalanced forces. How do unbalanced forces cause a change in the speed of an object? Okay, so remember, unbalanced forces can cause change in position, they can cause change in direction, and they can cause change in speed. If you have a skier at the top of the hill on this one, that's a balanced force, and at the beginning of the race, as he's going down the mountain, the unbalanced force causes him to actually pick up speed. Okay, the unbalanced force causes a change in speed. When he gets into a flatter spot, there will be less force pushing him forward because of gravity, and then he will slow down. But on the steep part, he's picking up speed. Okay, so a quick check for understanding. You need to decide if you can describe balanced and unbalanced forces, and if you can identify and describe how unbalanced forces cause a change in position, direction, and speed of an object when they are acted upon by unbalanced forces. Okay? All right, thanks guys. Let me know if you have any questions on balanced and unbalanced forces.